like to identify another county representative that is here. Kelly Jacobs from Eau Claire County arrived. Kelly, I'm not singling you out. Before you, please stand up. Before you arrived, we had all the municipal representatives stand up, announce their name, tell them what municipality they were representing. So thank you for being here. With that, I'd also like to identify any of the Wisconsin DNR staff that are here. And I think we'll just go around the room and you can state your name and what section you are with the DNR. We'll start with Ginger.
Ginger Cooper, and I'm with the enforcement section here in
Dave Johnson with the Groundwater section in Madison.
Jason Yazdecki.
Lacey Coleman, Public Drinking Water, out of the Baldwin office.
You're going to walk out.
Brad Johnson, Stormwater Program out of the Wausau office.
Chip Devlin, Stormwater Program out of Baldwin.
Eric Hennigsgaard, Stormwater Engineer out of Baldwin office.
I'm Bob Baczynski. I'm the runoff supervisor of the Stormwater Program. I'm also out of the Baldwin office.
Tom Willits, I'm the DNR statewide contact for all things industrial sand.
Deb Dix, Environmental Enforcement.
Mike Blodgett, I'm the Public Drinking Water Supervisor out of Eau Claire.
Dan Baldwin, Regional Director here out of Eau Claire. 19 counties this side of the state.
Okay, again, thank you, Wisconsin DNR, for being here. Before we take a short break, I'd like to just, so you folks, if you want a chance to ask questions or anything, you have been introduced to the municipal representatives that are here, the DNR representatives that are here. My business partners from my office that are here, John Bailey in the back, Anders Helfquist, and Nick Henneman. I know that there's individuals from Axley Bernelson, Mitch Olson. Mitch, would you stand? Ed Lawton. And then Buck Sweeney is here. And a special thank you to Buck Sweeney. Between him and Deb Nix, they brought this idea to us, and we were able to co-opt and host this event. So thank you, folks. At noon today, we will be serving a lunch here, courtesy of Axley Bernelson and Well Riley, Trent, and Ritchie. Will be served in this room here. We'll take about a 15-minute break.
Why don't we have the engineering? With all the air regulations, I know the small company probably were a little overwhelmed. Why don't we have the engineers so that if people have questions of the engineers?
Okay. We'll start with Tim and Ron from SEH.
What do you want, just an introduction?
Yep.
Yeah. Tim Marco with Short Elliott, Henderson, and Chippewa Falls.
I'm Ron Rubenzer with SEH, Project Engineer.
Other engineers?
Dennis Johnson with Ayers Associates, Eau Claire. Michael Strowski with Ford Incorporated here in Eau Claire.
Tomas Loro with Raymaker Associates in South City, Wisconsin.
Mike Van Gilder with Cooper Engineering in Rice Lake.
Stephanie Christensen, UCS Wausau.
David Wurzko with MSA Professional Services.
Gloria Wojnacki, SEH, Madison office.
Ryan Kronstedt, West Civil Engineers, Wisconsin Records.
Sharon Mushing, Cooper Engineering, Racing, Wisconsin.
I'm Ray Palmer with ESE Consulting, Blair, Wisconsin.
Warren with Graith, Milwaukee, and Madison.
That's with HNTV Corporation.
Anyone else?
Over here. Oops.
Ryan Franzini with Honda Lacrosse.
I'm Tom Kapinski with Summit Enviro Solutions out of St. Paul.
Ryan Bronson with Summit Bio Solutions.
Thanks a lot for the opportunity to be here. Just a little bit about myself. I've been in the groundwater section now for 20 years, working with all kinds of problem wells, and unfortunately recently an awful lot of work on high capacity wells. We'll talk a little bit more about that. Just one other thing in my background, fresh out of college, I spent a year in Texas oil fields, so I've seen Great Northern White in use. Alrighty. All right, the whole high cap process, what I'm going to try and do today is explain to you the high cap process with particular emphasis on the groundwater quantity review, the NR 820 review, and some of the legal stuff there. But to start at the beginning, you have to decide what are your water needs and look at your maximum capacity, your daily average, and you need to think about potable uses. And at this point, I'm going to have, where'd you go, Mike? There you go. Mike Blodgett's going to talk just a little bit about becoming a public system and how to go through that.
I was injected into the agenda this morning, so it's going to be fairly brief. As Dave talked about, your water needs for developing your system, whether it be a dry mine or a processing plant, and those are some very important distinctions that we'll try to get to a little later. But for a public system, at this point, people here, Dave, I'm kind of jumping ahead here a little bit because the application or the permit that you would need through my shop is in the public water would be the driller notification, and that's an 812 requirement. But that said, there could also be the potential for high cap that could go in under the high cap or a low cap application, depending on the type of property you have. And I kind of jumped ahead there, so Dave's going to cover that later, but there is a distinction there. As far as a public water system, the cutoff that we use currently is 25 employees, 6 months of the year, okay? And that's not one shift, that's total employees, that's office staff, that could be drivers or people working in the yard that have access to restroom facilities or lunchroom facilities. So that's the criteria that we use to determine whether or not you're a public system. The type of public system that you would be is considered a non-transient, non-community. So your requirements aren't the same as a community system, which might be like a municipality would be the easiest one. And I'm not going to get into a lot of those requirements. There are sampling and monitoring requirements that are found under NR 809. There are the well requirements that are found under 812. And then there's some operational requirements found under NR 811. And I don't have a slide, but later in the process I'll explain how we can get that information to you. So at this point, you've determined your water needs. You know, is it going to be employees on site? Is it going to be drivers? Whatever. You're thinking that you might have exceeded the 25 people total for 6 months a year. So either you're in the planning stages, or potentially some people here today could actually have existing systems that exceed those numbers. And what I want to make clear is we're not here to, or my staff are in the punitive mode. What we want to do is we want to get out to your system if you already exceed those numbers. We want to work with you, bring you into the public water arena, go through the Safe Drinking Water Act requirements with you, and get the staff covered with safe, reliable drinking water. that's our purpose. So there's no need to be afraid of us. So with that, I'll mention that at this point today, I've got two of my staff with me. They're both public specialists. And if somebody here has questions later on, they're both here with some of the forms. They can sit down with you and answer some of your questions and get you started. The first thing we're going to do is to come out and make a site visit, take a look at your facilities, or if you're in the planning stages and you have questions, they can help you with that too, because siting the wells, and there's a number of things that they can assist you with. So Lacey Hillman is one of the specialists. She'll be here. Jason Gazdecki is the other. So feel free to look them up. If you're in the planning stages and you're not ready to talk to them and you want to know who the proper person is to contact, at this point I'm just going to give you my contact information. And my phone number is 715-839-3745. Give me a call and I can put you in touch with the right specialist so that they can get out to get you started, give you a hand on the road to safe drinking water. So is there any questions? Thanks.
Thanks, Mike. All right, yeah, as I go through this talk, if you have questions, just holler up. I'd be happy to try and answer things while they're fresh in your mind. So you've kind of got stuff figured out about how much water you need. You've dealt with your public issues. Then you got to design code compliant wells. And it's dark up here, so I'm going to need my glasses. But one of my favorite parts of the code, NR 812, is 812.12, where it says, every well should be planned and constructed so that it will be adapted to the geologic and groundwater conditions of the proposed well site to ensure full utilization of every natural protection against contamination of the water-bearing formation or formations and exclude possible sources of contamination. Must provide bacteriologically safe water, adequate and contaminant-free water supply, conserve water, and allow for reconstruction. So those are all factors that you need to think about as you're working with your driller, your engineer, and designing the wells. Then you submit the application, and unfortunately right now what you do is you sit back and you wait. We are really quite behind, and there's two reasons for that. One is the Lake Beulah decision, which I will talk about in a little bit, and the other is the drought last year. We've been swamped with applications all through August, September, October. Every Monday brought in 20, 22 applications, and the rest of the week would bring in about 30. So we're a little bit behind. The other thing I want to say is you got to follow the conditions of the approval. I just did kind of a verbal emergency last week and told the driller to contact field staff, and he goes, why would I ever do that? Obviously he's not reading it because condition 4 of every application says contact the field staff. All right, just want to highlight a couple of key issues in the code. One is that you need to get an approval for high capacity wells. You can put in test wells, but if they go in greater than 6 inches in diameter, you have to notify the department that that is what you are doing. And you can run a pump test for up to 72 hours, but if you go over that, you need to get approval from us and contact us. And you also, for a pump test, 99% of the time you're going to need a discharge permit. And you're going to work with the wastewater people on that, the stormwater person in the county. Another thing that comes into play here is NR 812.13.16, wells within 1,200 feet of a mine pit or a quarry. And in that case, the depth that you go, Deb, I can't figure out where the pointer is. Oh, there it is. You got to reference the length of the casing, the minimum amount of casing, to the base of the mine. So if you're putting in a potable well, and it's in sandstone, you need 30 feet minimum below the base of that mine. If that's 80 feet down, you're going to end up down there in the 135 range. Yes, Buck?
If you take your situation where you have the mine and you have a limestone mine at 80 feet, now you're down 30, 40, and now you're taking frac sand off the bottom of that. What do you do with that particular well?
I think in that case, we would look at it that you take this, and this is sandstone now, that you do 30 feet rather than the 40 or the 60, because this would be either 40 or 60, depending upon the depth up here.
Before he goes down,
Yeah.
down another 50 feet.
Yeah, so then you'd go to the base of that as
Do you
being,
have to re-drill that well if it was an existing well?
either that or get a variance. Request a variance. All right. Now, I'm a big proponent of you guys knowing everything you could possibly know. And I have a sheet in the back on the table that has a whole bunch of websites that you can, and links that you can use to gather information. And I really highly recommend that you do all of that. You should have an inventory of private wells in the area. And you should look at those. And you should look at things like the specific capacity of the wells and get an idea of the transmissivity of the aquifer and really understand what it is you're looking at. You should look at the water quality data in the area so you understand what am I up against. I've dealt with a few sand mines where it's like, well, yeah, you could drill to there, but if you drill to there, you're going to have very high iron and mineralized water. You really don't want that. It'll mess up your processes. So let's redesign this well. In operation, you should be monitoring your static and pumping water levels, keeping track of your specific capacities so that you can look at things and understand this, not only understand the system, but understand your well. Is it time to rehabilitate it? Am I losing specific capacity? And you should be able to do a water balance. It's very simple. It's something that protects you and something that keeps you up on things. All right, now into high capacity wells. The definition of a high capacity well is any well or collection of wells on a property that have the capability of pumping 70 gallons a minute or more. That's 100,000 gallons a day. We've got one case in Marathon County that's got 27 wells that run between 4 and 12 GPM, but it's a high capacity property spread out over a lot of land. Anyway, uses, mining is there. Now, Buck and all you lawyers, you gotta forgive me. I'm a geologist, but I did take water rights law and environmental law. And I passed them both. The groundwater law in the state is one of reasonable use. And that was really established in '74 with Michael's pipeline. As a landowner, you can withdraw as much water as you want as long as you're using it beneficially and it's not to the detriment of your neighbors. And the high capacity law itself comes out of 1945, and it really comes from all the industrial use in World War II on the eastern part of the state. And the main design of it is to protect municipal wells. So you got to keep that in the back of your mind. But it has changed a little bit. You do need to have the approval. You got to have water use permitting in the Great Lakes Basin. That's part of the compact, one of the changes. Here's the codes that apply. Again, as Jeff said, good nighttime reading when you can't sleep. Okay, prior to 2004 in the groundwater quantity law, you had to just basically construct a well to 812 standards and not harm a municipal well. After the groundwater quantity law, that added environmental review for everything. Well, not for everything. But if your water loss was greater than 95%, if you were within 1,200 feet of an ORW, ERW, or trout stream, or near a spring of significant flow, 1 CFS is pretty big. All right. That all changed with the Lake Beulah decision in the summer of 2011, where the court said we had the authority and a general duty. And the case there, this is where I'll get myself in trouble with you lawyers, but basically we got sued by the Lake District because we permitted a municipal well kind of near this lake, and they thought it would hurt the lake. And we ended up winning the case, but at the same time we got told that we got to do this extra work. So win's kind of a so-so definition. Anyway, in it they said we have to protect the waters of the state. And the waters of the state include everything except for the guy spitting on the sidewalk in the rain, for the time being. So, I mean, it goes into artificial, public, impounded reservoirs, everything, which kind of complicates our groundwater quantity reviews. And again, this is part of why we're way, way behind. All of a sudden now we've got to look at everything and check on springs even below the 1 CFS and screen private for private well issues. And here's an issue that we're working on. Outside interested parties may compel further review and this and that. Right now we don't have any notification. Soon we will be having a system where the high cap well permits will be posted on a website. But I must warn you that we are getting lots and lots of information requests for the high capacity wells. We've got a number of people that routinely, every 2-3 weeks, send us an email, how many high cap applications, give me a list of them all. And then we send that to them, and then they come back and ask for 10 of the applications. And we have to scan them and send them out to them. So people are interested in it, people are looking, but the other big implication is we've got to avoid significant adverse environmental impacts. And you can go ahead and read that definition. I always get confused when I read it. This is not well defined. We don't know exactly how to deal with this. Some cases it's very clear. You know, you just go, oh, that ain't gonna work. But others are very difficult to try and do. But one of the ones that does come in that I have particular interest in because of some things you'll see later is the groundwater chemistry. So here's what happens. The application comes in, it gets processed, we take your money and deposit it in the bank, and then it starts into this NR 820 groundwater quantity review. And in it, we look at all the things, the trout streams, springs, water loss issues, wetlands, lakes, and all that, private wells, and the municipal wells. So it goes through that screening, and in the end, well, yeah, let me do this. Here's some of the tools that we use, and these are, some of them are on that sheet that I have on the back table, where you come in. You can look at WebView, DNR WebView, DNR Surface Water Viewer, and look at trout streams and all that stuff. We use stream flow depletions, drawdown models, the habitat model. This gives us stream flow where we don't have gauging stations. It's modeled. We talk to fisheries staff, we look at well construction reports, and all that sort of stuff. So it's pretty involved, pretty lengthy. What we'll do is we'll put a star on the map where it's going to be. We look at the well construction reports in the area. For those of you that don't know what specific capacity is, what it is you take the gallons per minute pumped and divide it by the drawdown, and that gives you a measure that is truly a measure of the aquifer's characteristics. And basically, you can take that number and multiply it by between 1,500 and 2,000 and get transmissivity in gallons per day per foot. And so that's a starting point. Again, I mentioned that earlier that you want to look at that kind of stuff. Here's the stream flow depletion model. We'll use air photos. We'll use gauging stations in this case. We had a bunch of gauging stations. All of those dots are springs. And we looked to Michigan because they did a lot of work on this as far as what is an allowable depletion in a trout stream or a transitional stream, cold water transitional stream kind of stuff. So we kind of rely on their data. This is just an example of one of the drawdown so that we can look at distance drawdown curves. And springs, on this we rely on field staff. We send them out. There's a high cap in this area. What do you know about it? Are there any springs? Any stream work being done, restoration, anything we want to not screw up. Also the Wildlife Federation's done a spring inventory. That's a report that can be gotten. For you guys, lots of springs in the area. Not that many 1 CFS springs in the immediate area, but lots of springs. So since 2000, you'd been doing this before 2004, it was an easier hurdle, but not anymore.
How do you affect that with the drought, and how do you affect it with high water in the river? Is that big difference?
You mean as drought in the well and
the overall drought like last summer, did that
Oh.
change the spring?
Yeah, it certainly reduces flow, and that's where you get into the professional judgment kind of thing. What's happening exactly? It does. Last year certainly did cause us more headaches than just 22 applications in every Monday morning. But we rely on as much as we can on historic data and historic flows and kind of plan that it's coming back to that. We look at the survey a lot for stuff. They've got a database called WSCLIF. If you're not familiar with it, it's basically all the geologic logs in the state. And that's every municipal well, every school well, every high capacity well in the state has cuttings sent into them for professional geologic analysis and formation calls. We look at pumping tests. A lot of sand mines have done pumping tests. We have some G-flow models in areas and mod flow models and hope to expand that stuff. Look at water table maps. This is just some pump test results. Then you get off, it passes all that, it gets approval. And ways that happens is sometimes we move the well further from sensitive thing, sensitive receptor, so to speak. Sometimes it's changing construction, case the well deeper, all that sort of stuff. There's a good example, actually. Where did I put that? I think it's on the sheet. The success story that we had where there was a quarry, and whenever they pumped, they drived up the spring, and Cooks Creek, it was a Kramer company. So Kramer cooperated, put a liner in, and everything's fine. Stopped the interconnection, and the trout, instead of flopping around and dying, now swim and are happy. But the things that we'll do is distance, where it can be, maximum allowable, reduction at certain times of the year when it's real sensitive, monthly limits, reduce well from other wells on the property. This is quite contentious with the agricultural industry right now. Again, deepening a casing, monitoring. This is also somewhat contentious. We have a CAFO that's challenging us on some monitoring requirements right now. But either way, you've got to do pumpage reporting. And it does say in every one of our approvals that we may look at having you report in the future water level information. And this doesn't happen often, reopening, but we do have a case right now that might go there. What was the other thing I was going to say here? Oh well, couldn't have been that important. Oh, I remember now. We have only really, Jeff said, well, we've never denied a permit until last year. As far as high capacity wells, we have only denied one permit that I'm aware of. So, we work with the applicant to make things happen. Now, Lake Beulah lets us talk about that well and any other wells on that property, but we can't look at cumulative effects. And this is frustrating for a lot of people, except for the guy next door who wants to put in a high cap well. And that's a problem. Another thing that doesn't really affect you guys too much is that Act 310 created these groundwater management areas, and these are areas where there's excessive drawdown of over 150 feet. And so you got the one there and the northeast one. This is yet to be really figured out. The Groundwater Advisory Committee did come up with some things, but we need additional legislation and rulemaking to make anything happen there. So it's sort of meaningless. And all we do with it now, you're in a GMA, something might happen in the future. Okay, so any questions on the high cap 820 process and the madness that it is?
What would you change on Lake Beulah if in a perfect world?
Nothing really. I think their decision was good. My biggest problem with it is it's generated such a workload, and we're so short-staffed that it's sort of a nightmare.
But is there things that you have to review because of that you might be able not to need to review, Dave? Is that or are all those things important?
Well, we're going through a lean process right now. Another thing that I don't necessarily agree with, but we are trying to streamline a lot of stuff and really put it together. But even with, say, a high cap irrigation well, the thing runs 3-4 months of the year. If you put that in and you don't construct it correctly and you've got atrazine and real high nitrates, those things are going to drain down into the lower aquifer and contaminate it. Again, you're back to 8-12-12 and stuff. So, you got to look at the water quality for every one of these, and you got to look at that construction and make a determination, and should it be altered? And we do quite a bit of that. We do go deeper. We do shorten the gravel packs to try and minimize those sorts of impacts. So, I wouldn't really change anything other than, and the court can't change our budget, but that would be the one thing. We need more staff. So anyway, kind of gone over, from a quantity standpoint, what you got is your high capacity well, your 820 issues, and then there's dewatering issues, lowering of the water table, changing of flow fields, and fluctuating levels. I'll talk about that a little bit more, but I'm really going to kind of get into the quality aspects of groundwater for you. I think key things that you can run into, fortunately with sand mining, you don't do a lot of blasting, but when blasting happens, you have rattling of old wells in the area. You get rust flakes, clogging pump intakes, and goofing things up and making neighbors angry. So you want to be careful about that with your shots if you are doing them. Spills, you've stripped off all the soil, you got to have a really good immediate spill response kind of plan going, because you have no assimilative capacity in those sandstones whatsoever. There's a lot of interest in the flocculants. So far, yeah, acrylamide's kind of scary, but we don't know what's going on with it really. There's a study out of New Jersey where they couldn't really find it in the groundwater. I don't think you will necessarily, but there is a chance for it in these sandstones. And actually, up in Chippewa County, a couple of the mines are looking for it. So that's nice of them. Oh, and I threw this one in. One last thing on quantity. This is the reporting from 2011. And the average percentage of capacity that was used in the months really get up to about 25%, and that's good. The less of that maximum capacity that you can use, the more recycling, the more conservation, the better. I've seen things where locals kind of go, wow, 3,000 GPM wells, and they do the math out 24/7, 365, and you know, you're like going, well, they're not going to be mining in scuba equipment, so I'm not worried about that, but it is something to be aware of, that it's good to keep that on the low end. So from groundwater quality again, the chemicals, the flocks, mentioned those. The blasting, increasing turbidity, the rust in that, and although I'm not aware of any cases in Wisconsin, I've read about cases in other states where nitrates become an issue from the blasting. So you just want to be aware of that. Again, that kind of goes back to, I know what the groundwater quality is in the area. I've done my homework. And then what is happening to it. On flow related, one thing I want to mention there that you have to be careful of. Your cone of depression can alter the groundwater flow. And I have seen this happen where a high capacity well has gone in, altered the flow enough that that septic plume that was going right by this well got sucked into that open interval of that well. And real quickly made the well unusable. So you have to be aware that those things can happen, and then you have to deal with them. So again, back to my you should know everything. There's a groundwater retrieval network, county studies. UW-Stevens Point's got a really neat site out now where they combined all of GRIN, groundwater retrieval network, that's DNR data, all DATCAP's data, and all of their data into a real nice viewer that you can just zoom in on your area and see what go through a whole bunch of different things, nitrate, atrazine, hardness, iron, all that stuff. One bad part about it is the western part of the state, people here don't sample that much. But another thing that can be done is you can run your own sampling programs for the people, your nearby neighbors. That's not uncommon. So flow related, I mentioned this. If you're going below the water table, you're going to induce radial flow and change that flow field. The influence of pumping of your high capacity wells can do the same thing. And one thing I find quite interesting with these large mines where you're stripping off the hill and ending up with this nothing but sand basin, you're probably going to actually significantly increase the recharge rates in that immediate area. So that's a positive thing in some ways, but it can also be a negative depending upon these flow changes again. That sort of makes sense? All right, I promised you this. I'm sick and tired of talking about arsenic. I've been doing it for 20 years now, but I have to talk about it. All right, what you got here is sandstone, and I'll admit this is St. Peter sandstone over in Winnebago County. And here you can see distinct black smudges of sulfide minerals. All right, problem is you have those same sulfides in the Tunnel City sandstone. And there can be distinct bands in other formations. Yeah, I'm going to show you some stuff to try and make you believe this and make you think that you need to think about it at least. In the Toma area, we had a well that was open to the Tunnel City sandstone. It had a pH of 4.6, sulfates up there, aluminum at 22,000. Standard for aluminum's 200. Nickel was at 1,200, standard's 100. Iron at 39, that's not palatable. When they went to put in the replacement well, when they were in that zone, they took a pH and it was at 3. We kept going. When the pH got up to 6.9, we set the casing. The new well's perfectly fine. In La Crosse, had this one well, was having problems. So they came in and they put in a 4-inch liner. 2 years later, go back out there because the problems are back. The bottom 40 feet of this liner is missing. You can see this is down to pop can thickness. All right, aluminum 1600, cobalt. I don't have the arsenic on here, but there was some, arsenic was about 27, I think, on this one. Drilled her a new well, same deal, get down way under it, everything's fine. Here's another La Crosse one. How'd you like to take a bath in that? This is a 2-month-old dishwasher. All right, let's see. So we did a geophysical log on this, and you can see the resistivity just wrapped all the way around at 527 feet. And you also see the temperature really kicking up there. And this reaction's an exothermic reaction. So we know where it's happening. So what we did was we filled the bottom of the hole. Now, come on. What? Sorry about this. Okay, these are the numbers before and after. Oh. These are the numbers before and after we filled in the bottom of the hole. So you got lead at 18, cobalt, that's standard is 40, iron at 150, nickel 500 basically. So we knocked this way, way down to where it was treatable, usable water. Here's another La Crosse well, aluminum 67,000. Okay, the reason you're getting real high aluminum is because aluminum solubility is 0. Nothing until you get below a pH of 6, and then it just skyrockets. Okay, so again, we're talking pHs down around 3. You got the arsenic, you got the whole suite. This is what I've been talking about for 20 years now. And I'm not talking about it in Winnebago. I'm talking about it in La Crosse County. Pierce County, this one's interesting. This particular well had arsenic at 2.3. The neighbor's well was 57. This one was the worst, though, on lead. That standard's 15. Again, zinc actually has a standard of 5,000. It's the only well I've ever seen go over that standard. But this stuff is all around. So what we've seen, too, the stormwater folks have seen pHs get down under that 6 and kind of bounce around in some of these deals. And so you're looking at this acid mine drainage, acid rock drainage, call it what you want, from sulfide minerals, or the potential for it to be jarosite, which is a byproduct of sulfide mineral weathering. And I threw up there ferric chloride, because that would be another thing if you were using ferric chloride as a flocculant to try and supplement your polyacrylamides or polydadmac, that's a possibility. But here's what jarosite looks like, chemical formula. Grind that up, add water, and you got an instant pH problem. Okay? So, if you start to see some of this stuff, you got to think about where it's going. The arsenic will bind on iron oxides and end up in your sludges and be fairly stable as long as you don't do one of two things. One is increase the pH, because if you increase the pH, you will desorb the arsenic and send it on its merry way in the aquifer. The other thing is if you apply a lot of phosphorus, because the phosphorus will basically just knock the arsenic off of that attachment site and steal it from it. Okay, so you need to think about your reclamation. If you're going to ag and you're going to lime, and you're going to amend the soils with manure, you got potential for some problems. All right, let's see if I see where I am. Yeah, you guys are lucky. I'm coming to the very end. As far as exploratory drilling, this is something that you can do, and you're welcome to do all of it that you want, as long as you follow the rules. Okay? These holes, if they're greater than 10 feet deep or intersect the water table, must be properly abandoned and filled from the bottom to the top with an approved material. Now, there's been some confusion out there, and it's self-inflicted by the department because we put stuff out saying NR 141 and 812 instead of 812, and it should be an and management liked 141 for two reasons. One is, in 812, the timeline for abandonment is 3 years. That goes mostly to its association with unused wells, but it does say drill holes right before it says 3 years. In NR 141, it's 3 days. Okay, so we like that better than 3 years. The other thing is in 141 actually opens up and is a little bit easier on materials that qualify. If you're on a small diameter core hole, it's cement if you're going under 812. If you're looking at 141, it's a little bit easier, so that's why management chose to kind of throw that one out. But overriding anything that's in 141 and its applicability is the fact that 812 covers it all. So please don't be confused about it. You drill a hole in the ground, you got to fill it. And then you've got to submit the forms within 30 days. That's where the downfall is. 141 says 60 days. So I wasn't there when they write it. I'm just in charge of 141. But if you've got holes in the ground like this out there, call me, call Deb. Let's talk about a plan to get them filled. We are getting a lot of calls from neighbors, landowners, concerned citizens about these. We will be following up on some of these leads. Yes, Buck?
Some of these old farms that people are now looking at and buying, you find the old windmills with wells that haven't been abandoned. When the new buyer comes in, just because they haven't been filled for years, as long as they fill them in a timely manner, the department's going to work with them, I would assume.
Oh, yes, yes. Yeah, for sure. And we're not, again, if you've got some out there, if you know of any, make a plan, talk to us, let us know about it, and we'll work with you. If we find them, it'll be a little different story. Is that okay, Deb?
Yeah, the only thing I would add to that, Buck's question, is that if it was a water supply well, it has to be filled by a licensed, The only thing I'd add to that is if it was a water supply well, it has to be filled by a licensed well driller or pump installer. It cannot be filled by yourself. So if it's an old pit well that was used for water supply, it has to be a licensed water supply.
For humans or for cows? Humans or cows?
Doesn't matter.
Doesn't matter if it was a potable, well, if it was a water supply well.
But the question was humans or cows, so.
Yeah, but these boreholes, your drilling company, you as a company yourself can do it as long as you're doing it to code. So I guess one thing I got up here, and I don't know if I touched on it, but they should be drilled with a method that allows that to happen. Hollow stem augers, nah, no, that's not going to cut it. These things, we find them, and these are a conduit for contamination into the aquifer. There's significant liability with that. So it is in your best interest to get them taken care of. Here's just some of the resources again. I've got this and more on the sheet back there right in front of Tom where he's sitting now. Feel free to take those. And you can contact me with questions and stuff too. Yes?
Are there funds available to close out wells?
For private well owners and stuff, I mean, the exploratory boreholes, no, but there are some matching funds that are available through the department, the well abandonment program that we have, and the counties often will have programs too. Any counties got an active program right now? Yeah, there we got one, at least one. They usually get some money here and there and have some money to do cost sharing for a while. No other questions? How am I doing on time? I haven't worn a watch since I stopped running.
So, Dave, what are the management implications for these mine operators? What are the management implications for mine operators that have sulfide deposits?
Well, I think they should be exploring it and looking at how to manage those residuals then, the sludges that come out and things. They need to be aware that they can have problems. I know I talked to one mine operator and he said, yeah, we were throwing some of that Tunnel City in and it messed up our whole process. You go, well, yeah, it'll mess up your pH big time, and you have some other things floating around there. One point I like to make, I guess I should make on this, again, you're going to mobilize under pH of 6, you're going to mobilize aluminum, you're going to mobilize lead, and there's no carbonate in the system out here where you guys are working to lock that lead up. It'll go a long, long ways. And nickel is also one. The arsenic, luckily, kind of drops out pretty easily, but nickel can be a real pain in the butt too. We had a quarry up in the Oshkosh area that had nickel problems, and they spent boatloads of money trying to treat it, and every time their discharge came out, they killed all the little fathead minnows, every time. So I would caution you to be aware of that, to consider it, look at it, be careful with it. Good.
Any other questions? If not, thank you, Dave and Mike.